Okay, so let's talk about the last area, this being the cerebral cortex. So cerebral cortex is kind of the topmost part of your brain. It's number 3 here. It's made up of 2 different hemispheres, so 2 halves, which we'll get to in just a minute. And it represents or accounts for about 85% of your brain's weight. It's also really squishy, so you can press on it and it flatten out to about the size of a big pizza. This area is particularly involved in the most special human functioning, so things that only humans can do and can also do at the latest in their evolutionary timeline, our evolutionary timeline. So, like I said, highest functions available are generally going to be in the cerebral cortex. These are things like perception, thinking, and speaking. It has about 20 to 23 billion neurons and 300 trillion synaptic connections. It's made up of several different lobes. So you have the frontal lobe, obviously kind of up here at the front. And this is where a lot of really high-end functions happen, along with other areas, especially planning, judgment, and behavior inhibition. So what we mean by behavior inhibition is as the name implies, stopping yourself from doing something. Okay, so if someone cuts you off in traffic, your frontal lobe is going to be generally responsible for you not throwing something at them, right? There's a lot of really interesting research on frontal lobe development in children. So what you do is typically you offer children in the lab, you say you can have 1 marshmallow now, but if you wait 5 minutes, you can have 2 marshmallows. Okay? And the idea there is that they have to show behavioral inhibition. They have to say, well, it'd be better to get 2 marshmallows, so I'll wait and get the 2, rather than just act on their impulse and say, oh, I'll get the 1 now. Kind of, you can see how that overlaps with planning and judgment. So what's interesting is that as the frontal lobe develops, you tend to see them pick the better of the 2 options. So really young children that don't have a fully developed frontal lobe, they're going to just pick the 1 marshmallow that they get right away. Those with the more developed frontal lobe that are a little older, they're going to say, no, I'll wait and get the 2 marshmallows later. You also have the parietal lobe. So parietal lobe is going to be about sensory information, particularly touch and body position. You have the occipital lobe, and this is going to be all about vision and seeing. So it's going to get a lot of input from your eyes, obviously. Lastly, you have the temporal lobe. This is going to be the green part, and this is going to be about hearing. Okay, so other functions of the cortex, particularly the motor cortex that you'll see here, this navy blue area, is going to also be directing muscular output, okay? Especially very complex muscular output. So when you're dealing with stuff like moving your fingers, say you're playing the piano or the guitar, stuff that requires really precise movement of limbs, that's going to have a lot to do with your motor cortex. Sensory functions are going to be the somatosensory cortex. So it's going to receive a lot of incoming sensory signals. And then you have association areas, and these are basically spread throughout your cortex, and they happen in several different areas, and they're particularly involved in those highest order cognitive functions. For example, the planning, behavioral inhibition, a lot of that is going to have to do with association areas in your frontal lobe.